Hey, hello, ladies and gentlemen. I'm hoping that you're doing well. And as usual, let me introduce myself. I'm Keya, Donicious, the principal Cubahiro International School in Burundi. And I am a maths teacher. I actually teach mathematics and I also do physics. Now today I had a class with my students and we discussed something in math, and I want to take long in my video, so I will go straight into the topic of discussion that we had today. And this was the topic, vectors. I had my year 13 class, A-level class, and we were trying to check around what does it, imply when somebody is working on vectors, solving questions or in one way or another, trying to work out areas around vectors. So in most occasions, it's good we always define something. So a vector, is a quantity. It's a physical quantity. It's a physical quantity with both magnitude and direction. Very, very important. So in this case, magnitude basically means size. It means size, the amount of something, some magnitude. So in most occasions, you will differentiate vectors and scalars. That was in your early days when you were doing physics, somewhere in year 8, year 9, and probably the early years of IGCSE in year 10, you did vectors and you did define what a vector is. And then most of the question was differentiate between vectors and scalars. And then probably a scalar is a quantity, is as well a physical quantity. It's a physical quantity with the magnitude only. So in this case, there is no direction relationship. So in a vector, there must be magnitude or size, then followed by direction. Very key. Now, if I can have two lines, this is one line, which is 20 meters. This is another line. Line is AB, which is also 20 meters. Look at these two. These are two lines. The first one has no sense of direction or direction indicator. So in that case, this is a scalar. This is scalar. And this is a vector. Goes for a scalar, it has magnitude only, the magnitude 20 meters. But for a vector, it has the 20 meters. In addition to the 20 meters, there is the direction, which is indicated by the arrow. So that is the main difference between these two. One is a vector, and the other one is a scalar. Very good. Let me use now the other side of the board and obviously show you something to do with the vectors. Now, for vectors under mechanics, if this is a vector, you see this line is neither vertical nor horizontal. It is a line that is at an angle to the horizontal. This is the horizontal and this is the vector. let me call it a vector F. Then this is the vertical to the vector F. This is the vertical to the vector F. Now, if that is so, then obviously the horizontal is the X Cartesian plane and the vertical is the Y in the Cartesian plane. Look at that. Very, very interesting. Now, if in any case I need to write X in terms of F, vector F, then obviously I will go for the obviously people know what this means. Sine, cosine, and the tan. And from this trigonometric equation, we'll be able to tell that this is the adjacent and this is the hypotenuse. The relationship between adjacent and hypotenuse is obviously here. Cosine adjacent of hypotenuse. So I can say the cosine of theta is equal to the adjacent x out of the hypotenuse f. So if you cross multiply, you say that x is equal to f the cosine of theta. So x is equal to f cos theta. What about y? Then I'll come here and say to theta, y is opposite and f is hypotenuse. The relationship between opposite and hypotenuse and theta will be, represented by the very first portion of SOHCAHTOA, and that is sine, in which we say the sine of theta is equal to opposite y out of f, something close to that, and so y is equal to f the sine of theta. So y is equal to f the sine of theta. Good. Take note of that. Take note of that. Very key, very important. So before I clear my board, vector is a quantity with both magnitude and direction. Magnitude is basically the size. Can be in meters, can be in centimeters. If it is a velocity, it can be meters per second, whatever that is. A scalar is a visible quantity with the magnitude point. The difference between a scalar and a vector is the sense of direction. Vector, there must be a sense of direction. This is clearly indicated by the two pegs and those lines down here. Without taking long, ladies and gentlemen, we have now seen that the x down here has got a special name. So if I may repeat my vector f, and this is my theta down here. This is my theta. So this is what we call y. The special name y vectors is a vertical component. It's a vertical component. And this is x, horizontal one. The special name with that in mechanics is horizontal component. This is very common in mechanics, very, very common. This is the vertical and this is the horizontal. I can comfortably say that the horizontal component is equal to f the cos of theta. I comfortably say here, we just remind yourself, the vertical component is equal to f the sine of theta. Very good. Vertical component. Mechanics students in most occasions call it VC is equal to S sine of theta. Horizontal component in mechanics, which they call HC, is equal to, we abbreviate it as HC, is equal to the cosine F sine theta, sorry here, and this is F the cosine of theta. We shall do an example. We shall do an example now. We shall do an example. Briefly, we shall do an example. There we are. And this is 30 degrees. And then this is the vector. Let me call it 48. Let me call it 48 meters. There we are. Question is find x and find y. Then you can say x is what we call the horizontal component, which is equal to f, of course, or theta, which is equal to f, 48 in this case. Our vector f is a general term. It can be a general symbol, which is 48, the cosine of that. Probably, if I need y is what we call the vertical component, which is equal to f sine theta, and this is equal to 48 sine of that. Then you go ahead with your calculator and get your answer. The answer should be in meters because our vector was in meters. That's the SI unit of that. And obviously, y will be in meters as well because our vector was in meters. When we meet next, probably we shall be able to do more. But for the meantime, I just wanted us to discuss, the general introduction on vectors, in which under mechanics, basically we are so much interested in the horizontal component of a vector and the vertical component of a vector, or how you can break a vector into a specific component, either you do it horizontally or vertically, very clear. And generally, horizontal component is the vector cosine of theta, very clear, and the vertical component is f, the sine of theta, very clear. And some example, you can be able to see that if you need the horizontal component of this vector specific one, then it is equal to f, which is equal to 48 times the cosine of the angle. The vertical component is equal to f, the sine of the angle, which is 48 the sine of that. And that's all. I think that's simple, clear, and I want to believe that the students that missed the class today in Cubahiro, year 11 students who missed the class, they can have this video and probably be able to check around. And I've said this because most students in the world, they fear mathematics, they fear vectors. When they hear that term, they get like, oh, what is this? No, it shouldn't be, because with time, they get used to them. It becomes so easy. Enjoy the day. Thank you so much.